Isn't it kind of crazy when you think about it? The phone in your pocket gets thinner and lighter every single year, but somehow it's more powerful than a beast of a desktop computer from just a decade ago. It feels like it shouldn't be possible, right? Like it defies the laws of physics. Well, today, we're going to pull back the curtain on that little paradox.
Right, so let's get into it, because this really is the central mystery of modern electronics. We all want our gadgets to be sleek, light, easy to carry around, but we also demand, ridiculous performance for gaming, for AI, for everything. You think it's a trade-off, right? Pick one. Well, it turns out you can have it all. And the secret? Well, it's all about thinking vertically.
That's the big idea right there. The solution isn't to spread things out wider and wider. It's to build up. Engineers have figured out how to construct these microscopic skyscrapers for the chips inside our phones, and this is the architectural magic that makes all of it possible.
Okay, so let's take a look at the actual blueprint for these tiny towers. The core technology that makes this all happen is called package-on-package, or POP for short. And this isn't just some tiny tweak or a minor improvement. It's the fundamental engineering leap that completely changed how our devices are put together. So here's the best way to think about it. Imagine you're trying to build in the middle of a super crowded city. You don't build a sprawling, single-story ranch house, right? No way. You'd build a massive condo tower to make the most of that precious ground space. POP technology does the exact same thing, but for the processors and memory chips on a circuit board. And you can see the difference so clearly here. On the left, that's the old way, kind of like suburban sprawl, with all the chips spread out, just eating up valuable real estate. But on the right, that's the POP way, the slick downtown high-rise. And it's not just about looking neater. That space savings is everything. It's what gives designers room for bigger batteries and what allows for those razor-thin phones. It's a total game changer.
So, doing it this way gives us 3 massive wins. First, and the most obvious one, it's smaller. That directly means thinner phones or maybe more room for something else you want, like a bigger battery. Second, it's actually faster. We're going to see why in just a sec, but by stacking the chips, the little highway between them gets incredibly short and quick. And third, it's super flexible. A phone maker can grab the best processor from one company and the best memory from another and just stack them together to create the perfect little powerhouse.
And this right here perfectly explains that speed boost we were just talking about. Think of the processor as the brain and the memory as the desk it's working on. In the old days, that brain and desk were on opposite sides of the room. You'd have to shout instructions across a huge hall. But with POP, they're stacked right on top of each other. It's like whispering. The signal is way faster, way clearer, and it uses a whole lot less energy to get the message across. Okay, so we get what it is, and we get why it's so great, but how in the world do you build a skyscraper that's smaller than your fingernail? Well, the manufacturing process is, you guessed it, just as mind-blowing as the idea itself. All right, let's take a tour of this micro tower. The whole structure is anchored to the phone's main circuit board by its foundations, hundreds of tiny solder balls. Each level has its own floor, which is really a mini circuit board called a substrate. The tenants living on these floors are the actual silicon chips themselves, the brains of the operation. And how do they talk to each other between floors? With microscopic elevators made of even smaller solder balls or tiny gold wires. Incredible. Now, putting this all together, you'd think it's all lasers and sci-fi. But the best analogy is actually baking a cake. A ridiculously high-tech, multi-layered cake made by robots. First, a machine spreads this cream, which is really solder paste, onto the board. Then, a super precise robot comes in and places the chip layers with an accuracy that is just hard to even comprehend. The whole thing then goes into a special reflow oven to bake, which melts all the solder and forms perfect electrical connections. And since you can't just slice it open to check your work, they give the finished cake a CT scan with an X-ray to make sure every single one of those internal connections is absolutely perfect. So, as you can probably tell, this whole process is insanely complex. And that complexity is what forced the big tech giants to get really creative. They couldn't just use the standard off-the-shelf method for this. Nope. They had to invent their own, better ways to build these towers. And this is where we get to see the unique personalities of Apple, Samsung, and Qualcomm really shine through. Yeah, the standard way of doing things just wasn't going to cut it for these guys. So each one developed their own unique architectural blueprint for their chip skyscrapers. And what's so fascinating is that these technical decisions, they're not just about hitting performance numbers. They are a window into the soul of each company, a direct reflection of their entire business philosophy. So let's break down these 3 rival blueprints. You've got Apple, who, working with TSMC, basically 3D prints the connections around their chip. Then there's Samsung, who builds this custom high-speed bridge to connect their own components. And then you have Qualcomm, who focuses on creating a super reliable universal platform that can be mass-produced for hundreds of different phone models around the world.
So first up, Apple. And their approach is pure classic Apple, ultimate integration and total control. Instead of just placing their chip onto a pre-made floor, they basically print that floor and all of its wiring directly around the chip itself. This completely gets rid of extra layers and other components, making the final package unbelievably thin and efficient. It's just so Apple, obsessively engineering every single tiny detail to create one seamless, perfect product.
Then you've got Samsung, and they're playing a totally different game. Their unique strength is that they make everything themselves. They make their Exynos processors, and they make some of the best memory chips in the world. So they built a special, super-fast silicon bridge. It's called an interposer, to connect them. It's like they built their own private superhighway between their own buildings, just to show off that they have the power to control the whole supply chain.
And finally, there's Qualcomm. Now, they've got a different problem to solve altogether. Their Snapdragon chips have to work flawlessly in hundreds of different phone models from dozens of different manufacturers. So for them, the blueprint isn't about being the absolute thinnest or the most custom built. It's about being incredibly robust, super reliable, and easy to mass produce. They created the ultimate universal platform that just works no matter where you put it.
So, these incredible little skyscrapers have made our modern connected world possible. But as we keep trying to build them higher, packing in more and more power, we're starting to slam into a very old, very physical problem. The next great challenge is all about heat. I mean, think about it. You're cramming all of that computational power, all that data flying around, into this tiny enclosed space. It's going to generate a ton of heat. And as we demand even more from our phones, for AI, for console-level gaming, our chip skyscrapers are getting taller and denser. And with all that density comes heat. It is the single biggest physical wall that engineers are running up against right now. And that leaves us with the critical question for the future of, well, everything. How do you air condition a skyscraper that you literally can't even see? The company that solves this puzzle, whether it's with new materials or micro-liquid cooling or something we haven't even dreamed of yet, they won't just build a better phone. They're going to build the next generation of technology that changes our world all over again.